So this problem is about cell phone service and whether or not people look up their health or medical information, look up any health or medical information using their cell phone. So this is Pew's Research Center's Internet in American Life project, and they took a random sample of 2,485 cell phone users and asked them this question, whether they had used their cell phone to look up any health or medical information. So of these, 422 said yes. So the first part of this question asks, so Pew dialed cell phone numbers at random in the continental United States in an attempt to contact a random sample of adults. So based on what you know about this national sample surveys in general, what is likely the biggest weakness in this survey? So it's arguable what the weakness is. You could argue that some people don't have cell phone service. If they didn't have cell phone service, then they probably wouldn't use their cell phone to be looking up health or medical information. But you could also argue that the continental United States does not constitute the entire United States. It leaves out the outliers, Alaska and Hawaii. So there's two states that are not even accounted for in this survey. So I guess you could make that argument. But Part B just says, well, okay, let's just assume that this is a simple random sample, and they want you to give a large sample, 90% confidence interval for the proportion of P of all cell phone users who have used their cell phone to look up health or medical information. So when you see a question like this, just like the other questions, you need to ask yourself, well, is this a large sample? Is it large enough? And so we look at the numbers here, and we have 2,485 is our N, and we have our yeses, so our successes, are equal to 422. Those are the 422 people out of the 24, roughly almost 2,500 people surveyed that said yes. So our success is someone who said yes. So we look at that. The 422, if you recall the rule, we need, the rule is that we have, I'll just write the rule up here. Rule is at least 15 successes and 15 failures. And so we have 422 successes, and if you subtract 422 from 2,485, you have well over 15 failures. And so we can actually do this analysis using a large sample. So back to the question. So the question is, they're looking at 90% confidence interval for the proportion P. So we need to figure out what P hat is. The proportion P is P hat. So part B is essentially saying, P hat, we don't know P hat. We have to figure that out. And we also have to figure out what that confidence interval is. So we need to know a few things. We need to know the standard error, and we need to know the actual confidence interval. And so we can actually derive both of these using formulas that we know. So let's start with P hat. So for P hat, we know that that's the successes over the total number. And so we know that this is 422 over 2485. And so if we do some math here, we can calculate this. So 422 divided by 2485 should give you roughly 0.17%, and I'm rounding up here. So, or 0.17, 17%. So 17% are saying yes to this question. So now we know our P hat. So we need to figure out what the standard error is. So standard error is just the piece of the formula for the margin of error that doesn't include that critical value that's the multiplier. So to figure out the standard error, we simply use SE equals the square root of p hat times 1 minus p hat over n. And so this comes out to be the square root of 0.17 times 1 minus 0.17 over 2485, which comes down to, I'm going to type this in, so this is 1 minus 0.17, which should give you 0.83, so 0.17 times 0.83 over 2485, and then we take the square root of that. So 0.83 times 0.17 is equal to 0.1411. 0.14, we'll just say 0.14 for the sake of argument, and then that's going to be over 2485 still, and we're still taking the square root. So let's divide that by 2485, and we get it's the square root of 5.68 times 10 to the minus 5, which is a very small number. And then if we take the square root of that, you should get 0.008. And that should be the number that you get, or 0075, depending on how you want to do this. So this is our standard error. This is 0.008. So now we need to calculate the confidence interval for this standard error. So using this standard error. So we need to look at our table here. And I'll try to squeeze it in here so you can see it. But here you can see we're looking for the 90%, which is right here, based on what they're asking here. So 90%, we'll look for our critical value, z, and we find that it's 1.645. So our margin of error is going to, or m, is going to be equal to 1.645 times 0.008. And if we do that math, 1.645 times 0.008, we get 0.01316. And essentially that's saying that they actually got a different number in the book for some reason, but I'm just looking at this. So, but actually we get 0.01316. We might have just put a wrong. Oh, I know what it is. They actually rounded to a larger number of decimal places than we did. Actually, they didn't round at all. So that's why they're actually getting a slightly different number. But essentially, what this is saying is this. We can call this a 1.3%. And so we can say with 90% confidence that our range, if we were to take another sample and we were to get the sample proportion, that it would be somewhere between, if we look on a curve, I'll just draw a normal curve here, and we know that for this particular case we got roughly 2%, let's say. It was 1.7%, and maybe I should just say 1.7% here. And we know that we can say that with 90% confidence, it's going to, if we did another sample, it's going to lie somewhere between 0.7 and or 0.7 or maybe 2 on this side, or 2.7, let's just say, or 0.7, and 3. You're basically adding 1.3 and subtracting 1.3% from this 1.7. So we can say this with 90% confidence that that is the case.